Have you ever wondered how atoms come together to form molecules? Well, chemists have too. And one of the most popular theories is called molecular orbital theory. Molecular orbital theory dictates that when two atoms come together to create a molecule, they create something called a molecular orbital, and it has a bonding orbital and an antibonding orbital. The bonding orbital is the orbital that tries to keep the atoms together. Meanwhile, the antibonding orbital is the orbital that tries to push the atoms apart. If the number of electrons in the bonding orbital and the antibonding orbital are equal, the bond is never formed. Additionally, antibonding orbitals are both higher in energy and have an additional node, which means a region where electrons cannot exist, that bonding orbitals simply don't have. These two orbitals are caused due to the atoms' wave functions. They can have constructive interference, which is when two people do a jiggy and it makes the jiggy even bigger, or it can have destructive interference. That's when two people do the wave, but they do it in opposite directions and it's just kind of awkward and it does nothing. We can display these molecular orbitals in diagrams, where each atom brings its electrons and puts them into little baskets, the bonding orbital and the antibonding orbital. First filling up the bonding orbital, since it's lower in energy, the number of molecular orbitals will always equal the sum of the number of atomic orbitals. With this, we can calculate something called the bond order, which is simply 1/2 the electrons in the bonding orbital minus the electrons in the antibonding orbital. This number, the bigger it is, indicates a stronger bond between the atoms. Once we get to more complex atoms with more electrons, we know that the previous levels are already filled. In the case of oxygen, for example, the 2s layer is already filled. Once we get to the p orbitals, there is something called the sigma orbital and the pi orbitals. And as we can see, this one has a bond order of 2 and is paramagnetic, meaning it has at least one unpaired electron. But what exactly is the difference between sigma and pi orbitals? Sigma orbitals are shaped like this, meaning that no matter how we rotate them, they will always look the same, so we can only have one without overlap. However, pi orbitals are shaped like this. So due to their geometry, you can fit multiple of them, such as this, and this, all in the same atom. That is why there are 3 slots for the p orbitals in the molecular orbital diagram, 2 for the pi p orbitals, and 1 for the sigma p orbital. Their differences are more than just geometry though. Sigma orbitals occur when head-on-head collisions of orbitals happen, and pi orbitals are formed when side-by-side overlap of the orbitals happens. This is why sigma bonds are stronger than pi bonds, because sigma bonds physically have more overlap between each other. One final note. The MO diagram for oxygen displayed earlier is not the only type of MO diagram. If we see the one for nitrogen, for example, we can see that the MO diagram has its pi and sigma bonding orbitals flipped. This is because oxygen and the groups after it have something known as sp mixing. Sp mixing occurs when an atom's sigma and pi orbitals are so close in energy that they flip. This only happens to atoms in group 16, 17, and 18. From nitrogen to the left, the pi orbital always comes before the sigma orbitals in the bonding. Well, that'll be all for today. Please hit like and share, and see you in the next one.